Right, okay, this is another update. Now I've just finished putting transfers on this new circuit board which I've made, and sorry at the camera might steam up occasionally because I'm using boiling water and I'm about to add my etching solution to etch the circuit board. I thought I'd just show you this. I've made the circuit board because the resistors for my solar panel charge for the batteries was overheating. Well, I expected that because we get surges, and I don't want to use too high value resistors or high wattage because, well, to be honest with you, they're quite big and I haven't got much room in the battery box now. So I'm just going to use using lower wattage resistors, and I'm also going to be using some more diodes in this next situation. I'm just going to add some of my etching solution, which this is recycled. I used this last time for doing another little board, but I'm going to have to add to it because there's not enough. I'm doing this in a bowl with boiling water because the heat helps the solution to actively remove the copper. Right, now we're in business. It's going to take a while to etch this. I know, I don't suppose a lot of people have done this on YouTube. I don't know, maybe not, maybe so, I don't know. But anyway, I just thought I'd do it because my daughter was interested in it, and I think she wants to see what it does. Anyway, it takes a while, so what I'm going to do, I'm just going to pull it up and show you at the moment where we are at the moment. Right, you can still see the copper. Right, I'm going to stop the video. I'm going to restart it when I get sort of through this, because this could take probably 10-15 minutes to etch. So as you can imagine, I've got a little board in there as well. Actually, I should have done that separate because it might scrape the transfers off if I'm not careful. Just going to move it out of the way. That's better. Because I've got boiling water in here, it heats the chemical up and helps it work faster. Also, it's a bit of an insurance policy. If I happen to get acid on my hands, at least, well, it's not boiling anymore anyway, it's just hot now. I could wash it off immediately. Anyway, so I'm going to stop the video and I'll restart it in a few minutes when we've made some progress. Okay, been at it a few minutes. Now you can probably see that there are some areas that are showing fiberglass now. You can see the lighter colours where the copper is disappearing. The copper is very, I'll just call it a bit closer. It's hard to tell, but you can see that the copper is actually disappearing in the solution as we etch this, and we're making progress. And hopefully once this is done, I'm basically going to put the diodes and the resistors for the solar charger on the circuit board, and I left a large area of copper in the middle of this board, which will be quite clear once I've finished. And that will act as a heatsink and help to dissipate some of the heat, because I don't expect the diodes to get that hot really, but having a large area of copper is very useful, especially when you thicken it up with some blobs of solder. It acts as a kind of nice heatsink, because I am limited with space in this solar battery, and I don't want to be having protruding heatsink sticking down between the batteries simply because it might short on something and we might have a little mishap. But oh yes, look, you can see now there's a heck of a difference. Now parts of copper have gone in between the tracks, and other parts of the copper remains. We've still got a little way to go yet. Right, that's it. We've accomplished our task, and now I've got to actually take the board out and wash it and scrub it up and clean it and polish it and all that. There were some little spots I'd missed, but I can pull them off with the soldering iron when it's done, because the more you do this, there's a bigger chance of any hairline cracks that I might have missed with my little pen, that they might open up. So I prefer to stop at this stage. So we're going to get my tweezers. Use one finger because I can rinse it. Now we can see that this copper's gone between the tracks, and what the paint transfers. I'm holding the tweezers at the moment so I don't get any stuff on my fingers. And right, so got all the copper off. I'm just going to dunk this in the hot water now. Take the acid out and stick this back in a safe place where it won't get knocked over. I don't want to do that. Right, get the other one out. That's a little board. It's actually the reason I made a little board was because I decided to add something onto this board. I could easily solder it together later, join it. Oh, I better wash my tweezers. Right, I'll stop this and get rid of this. That seems to have worked. Okay, I was using ferric chloride crystals. I've actually had them about 10 years in a stored away. Still work. Now I'm going to use tetraclean, actually engine cleaner. It's just to dissolve the transfers and the, if I can get it to squirt. You can use all sorts of solvents really. Doesn't matter really what you use. The point is, all we need to do is get rid of the ink and the transfers off the circuit board. And this seems to work quite well. Anyway, I'm going to let that soak a minute. Then I've got to scrub it and wash it. I'll use my paintbrush to loosen any stubborn bits. Making circuit boards isn't that difficult, you just need a lot of patience. Obviously the ink comes off first and the transfers take longer. I'll probably have to scrub them off actually with I know a lot of people use photo etching these days, but when you're just doing a one-off, there's not much point really. I mean, you design it on a transparency only if you really want to make multiple copies anyway, but I'm just doing a one-off. The transfers are coming off now. Good. Anyway, I'm going to stop the video because it take a while. Well, we're just about finished now. I've done a little one. I've just got to go and rinse. You can't see it very good at the moment. I'm going to go and rinse it and soap it off in the sink. I use a little bit of, probably a bit of scouring powder like kitchen cleaner or something just to finish it off, get rid of the grease. I usually use that first actually, but the trouble is it doesn't get rid of the ink too well. The ink is very stubborn because it's so bouncy and it smudges. So I thought, well, I use solvent first because I used quite a lot of ink on this one. So anyway, I'm just going to go and rinse this out and I'll be right back. I've just washed it. I'm just drying it now in a bit of tissue paper. And then I've got to drill it, ready to. I don't actually need to drill this one though, because I'm going to be mounting the components on the copper side rather than on the other side. You see, you normally put the components on the, oops, not the camera, normally put them on the back, obviously on the back of the circuit board, but because this is going in my battery pack, it's going to be laid flat on top of the batteries, and obviously if there's components there, they could come into contact with the circuit board and short things out and I don't want that to happen. So actually I don't really have any surface mount components at the moment, but it doesn't really matter. You can mount ordinary resistors and diodes on the copper side. It's just a little bit more fiddly. Anyway, that way I've got insulation. I've got that I can use the back as a good insulation because this is Paxolin. Paxolin is used most commonly in cheaper radios. Fiberglass circuit boards are using more expensive electronic devices, but and it's much more resilient. It can withstand knocks more, but Paxolin can be very brittle. And I've got a few little bits of Paxolin here, and I'll just show you what I mean about Paxolin. It's not very, it's not very strong. This is a little chunk of Paxolin, and it's just the copper that's got where I've cut it wrong, and it actually breaks easy. So that's a piece of it just come off there. It's actually very easy to break, but I'm not worried about that because it's just for the battery, and it's going to be laid flat anyway on some foam cushions. The idea is to use it as well, I'll just show you a little bit, but I've made some pads. I don't know if you can see too well, but there's some little pads there made, and there, and I've got to drill some holes in the large copper area over here for the other end of the resistors and diodes, and this large copper surface here, this whole area is going to act as a heatsink and help to dissipate heat, spread it out. Because I had a bit of a problem, my solar panel was doing so well today, or earlier yesterday actually, that some of my resistors overheated, and like I said, I expected some would burn out. Now here's one of my resistors. Now that looks a little bit yeah, burnt to say the least. This is what the resistor is. Oh, let's see. These are the new ones. This is what it's supposed to look like. So you can see what I mean. My resistors got fried a bit, entirely by act of God, solar power. So I mean, it's not like anyway, I expected something like that to happen, because it also showed me a little bit about where the current needs balancing out more, some of the cells, and so I made the circuit board, and hopefully this will do the job. Actually I burnt two out, there's two burnt ones, that's all I did, the rest of them are alright. So I've actually got some wire wound resistors. Now these are heavy duty, 1.8 ohms. I don't know if you can see that, but a little bit too heavy duty for what I want, and the resistance is very low, but I've got a few of those, but I prefer not to use those because it's not going to get that much power, and plus these ceramic ones, they generate quite a lot of heat, and in a confined biscuit tin, that heat is not a good idea. So my objective really is to minimise heat, if anything, just to, I mean, heat is wasted energy. It's when you generate heat in an electronic circuit, that is wasted energy, and if you had a really efficient circuit that worked without generating any heat, then you would have less percentage of loss of energy. So I'm probably just going to do away with some of the resistors and use diodes and equalise the current to the battery cells that way. And I've got some thermal fuses. Where are we? I have some thermal fuses. These are the ones that come in laptops. Now that's a specific thermal fuse you might find in a laptop battery pack. Now the power goes in this. Oops, get it right way around. This end. I'm sorry, wrong end. Sorry, the power goes in at this end, and it comes out that end. That's the pointy end. So that's generally how you. I don't suppose it matters with these particularly, but with diodes it does. With diodes you have to put the positive. Let's see, I can show you. Got a bunch of those here because I never really said much on there. Here's a bunch of new diodes. Positive goes in at this end, and it comes out this end. If you try to put positive in this end, it will not go anywhere. It won't come out the other end. It's a one-way street basically. If you know what a one-way street is, where you can drive down it one way and you're not allowed to drive it the other way, well, that's the basic law of a diode. It allows current and voltage to flow in one direction but not in the other. Anyway, just a little bit of basic information there. Probably going to be using all these actually. Anyway, I'll better stop because I'm going to be doing a few holes anyway, because I've got this little socket thing to put in. It's a solderless plug to plug the wires in, and I've got to put that on, and just change the bush in my drill. The right way around. I don't know, I've got to find my little drill now. Oh, I think that one will do. Oh, what's my tweezers now? It's amazing, isn't it? Whenever you want something. Oh, there they are. They actually got blanched with copper, look. When I dipped them in. I only dipped them in a little while, and these little drills are so tiny, I've got to use my tweezers. You get an idea how tiny these drills are. If you do electronics yourself, you'll know all about this, but my daughter doesn't know much about electronics, so, and she was interested in a little bit, so that's the reason why I'm giving little details that might seem irrelevant to most people who know all about electronics. I actually know quite a lot. I've got a lot of years experience in it. I used to do hi-fi repairs a few years ago. My eyesight got really bad though, to be honest with you, and most of the time I just can't be bothered. But it's different when you've got a purpose. When you have a purpose, when you have something you're interested in accomplishing, then it kind of makes it worthwhile, if you know what I mean. I've got to use pliers to hold this because otherwise they skid around, they don't always grip very well. I've actually got the tiny drill because I'm drilling the small holes first, simply because then I can use, oh, I need to switch the power on. I'm actually using my solar battery to run my drill, by the way. Which is interesting. Right, so it's only running at the voltage that the batteries are running. It's not running at full power, but that's okay. I need to drill these because they're anchor holes anyway. I need 12 volts really. Paxolin isn't that hard to drill. I really need to be drilling on a raised surface, otherwise I'm going to be lots of little tiny holes, and I think I've got woodworm in my table. Oh yeah, that's happened before. I thought, oh, I've got woodworm, and it wasn't woodworm, it was just that I'd forgotten I'd drilled a circuit board on it at some point, and yeah, kind of embarrassing. That's why I dimple it with the transfers. You've got to dimple it so that your drill can find the middle. It can be kind of fiddly. I'm not going to record all this because I tell you it's really boring. It's like watching paint dry. It really is. But drilling the holes helps me to see where the components go as well. I don't have to put the components through the circuit board, like I said, because at certain situations I might be safe, but I don't want to short the batteries out. No. Not in the hole. Right. My drill's blunt. These drills are expensive and I can't afford to buy any more right now. That's another reason why I prefer Paxolin. It's easy to drill than fiberglass. Fiberglass it really does blunt your drills because it's much tougher. It's a much tougher material. Right, let me see. I've got more holes to go yet. I'll get in the hole and see in it. Anyway, I'm going to stop the video because it's using up a lot of tape. Right, I've got all my holes drilled. I tell you, it's annoying when you drill a load of holes and you've got maybe lots of them, especially when you're doing integrated circuits. And you put everything together and then you find out you missed a hole. There's one you haven't drilled. It's really annoying, especially when you've got all the wires soldered in and everything, and you think, damn it, I've got to drill a hole. You've got to go and get your drill out again. Anyway, don't know if you can see them. Not very easy to see on the camera, but turn it round, you can see on the other side, see where the light shines through, and that's the other side. So there's a lot of holes. Actually, there's always more holes than I need, just in case I need to add a wire or something. Anyway, yeah. Oh, I've got to solder this bit on. I've got a little bit of add-on circuit. Later on I'm going to stick it on, and then I'll put some solder across to join them two together, a bit of copper or something to hold it on, and then once I've got it tagged on, I will get some fiberglass resin and run a little bit of it down this crack down here just to stick it together properly, and then it will be full piece. It's just the problem was, you see, I'm using bits of circuit board I had left over from before, and I thought, well, rather than wasting it I'll just tag it on, because I need it this length, because it reaches the full length of all my batteries. Saves me having wires everywhere. Then I can just basically tag a wire on wherever I want along the track to the batteries, and I've not got wires floating around and the risk of wires melting and things like that. That's the idea. Minimise the risk of fire or anything, and just have a wire from here to B, and that's the reason why I've got all these long tracks, because I don't really know exactly where I want to be soldering the wires on at this point. It depends on when I match the batteries up. Plus I can also move the wire from one track to another track if I want to change one block of battery cells to a different cell cluster and different resistor network. It's easy to move it along. That's the other reason why I want it this way up, not the other way up. I tell you, if I built it and put it that way up, I would have to take the whole thing apart just to get to the damn the solder track. That's why I want the solder track on the top. Makes it easy to plan and change things. And oh yeah, you're probably wondering what it was. Is there a fuse on here? Actually, no. The reason is I've got a thermal fuse. I'll just show you this if I can find it. I'll just pause a minute, if there is a pause. I don't think there is. Oh yes, there is. Hang on. Oh, it doesn't work. That's great, isn't it? Right. I found it anyway. Right. This is a thermal fuse. I'll check it. I've stuck it in now. It's a thermal circuit breaker. Actually, you know what a circuit breaker is. You can't see it's rubbed off. Now, I've had this a long time. Actually been lying around in my cupboard for 15-20 years. 3 amps, but it'll do for what I want. It's safe actually with it being 3 amps. The general idea is if you take too much current out of the batteries, it flicks the switch and you've got to reset it, just like a normal house trip. You know, when you have a fault and your fuses go, instead of having to replace fuses, you just reset it. Well, this is what this is. So I'm going to be sticking this in at some point. It's only 3 amps, but it'll do. I don't plan on taking a lot of current out of this thing at a time anyway. I'm only going to be using a 300 watt inverter, so I don't think, hopefully that's not going to be taking more than 3 amps, but if it does, then we'll have to rethink things. Probably get another trip, or a different trip or something. But yeah, I'm going to be putting this, I mentioned this earlier, this little thermal fuse. Now, I forgot to mention, I think, actually the way it works is if it gets above a certain temperature, it blows and cuts power off. These things, they blow once and you've got to replace them. They're not resettable. So I'm not actually sure about the temperature on this, but it came out of a laptop battery pack anyway, so I assume it's a safe one to use. But that's probably going to be going pretty close actually. I'm probably going to mount this. You can see I've left some gaps in the tracks here, look. well, I can probably mount this underneath through there. I'm going to have to make these holes bigger for this and have it close to the battery, thermally bound in contact with the battery, so that I've actually got some in there already on some of the cells. But if the batteries actually do get too hot, then which they won't, but see, if they did, then it would blow that. But the trouble is, I've got so many batteries, it's kind of difficult. That's the reason why I put that other thermal cutout on the front plate originally. It covers everything really. I don't really need this, I suppose. It's kind of pointless because it's only viable if you're monitoring one cluster of batteries, and it's a lot of messing about having them on every single cluster, because I've got, well, let's see, I've got 15 blocks of batteries, so I mean that's a lot of, that's 50, no, 13 times 6, so that's a lot. I mean, that little thing's not going to do much, is it? Can't monitor them all with one or even two of them. So anyway, we're gonna. Anyway, I'm gonna wind off the video for now because I'm falling asleep. Oh, right, wrong way up. I think we're back to normal. Right, okay, the new solar panels charging. Oh, still a long way up. We're jumping around between about 1 amp and half an amp. It's the sun's up and down. Right, I've got the new solar panel. It's really big. Sorry, I can't really show you the front of it because I'm inside. But it goes right to the top of our window, and it's been going behind the tape recorder, which holds it up. It's like a big brick. Right. Here we go, the 1.3 amps at the moment. It's varying. .28. Right, I'm going to show you my board. Take the lid off. Right. So I haven't got the right dimmer. Right, there's my circuit board wired up with the resistors. I've got some resistors and some diodes on there. And because it's all, and there's a thermal resistor there, a little orangey thing in the middle there. That's on the charge circuit. So if for any reason it overheats, so it gets too much power coming in, it temporarily, it's called a momentarily thermal trip or something. Basically, when it gets really hot, it trips and cuts off the power until the current drops to a certain level, then it comes back on again. So it's a safety device. I've had that quite a while. They're quite expensive, those little things. And there's my other diodes I've got linking to. I haven't got many straws now. I've taken them out, but I put all the diodes in the middle of the board. I've done away with a lot of resistors. Sorry, my microphone's a long way. So this design's better now. I've got a lot less wires and less straws floating about. And I can take wire tappings off to the different cells to minimise all the clutter, and obviously if I need to move a tapping from one battery source to another, it's not difficult to rearrange the wiring because I just move it to a different track on the circuit board. Anyway, that's it. I went out of solder actually. So I've been scrounging for old circuit boards and nicking the solder off the old circuit boards because I'm a bit hard up for solder at the moment. So when I get some more solder, I'm going to thicken some of these, tin all these tracks, because a lot of the copper tracks are still bare, and I'm not going to spray it until. Oh, and that's the thermal fuse. That orange, big orange sausage thing there. That's the laptop fuse. So if it overheats, that cuts out and it stays off. But there's two set of fuses actually. There's that one, and there's my orange momentary trip. The momentary trip obviously will cut out first, so hopefully that big one won't blow on unless something serious happens. But yeah, anyway, I'll just zoom out. As you can see, about 1.20 amps at the moment. It's hard to see because of the light shining on it. That's better. That's the charging anyway. So it's going alright. The voltage actually looks lower now. That's because I moved the meter tap in, the wire that the meter's tapped. Instead of being tapped directly to the batteries, it's now tapped it to a diode after it's been through the batteries. So there's a voltage drop of 0.7 volts. So it will look lower, but the voltage is actually still good. I might have to amend my label because I recently recorded it at 7.57. But obviously there'll be a bit of a voltage dip, but I don't mind because that means the voltmeter will actually go off earlier if the batteries go flat below 6 volts, saving power. No point in the voltmeter running if the batteries are already on the way down. If it goes off, it gives me an instant indication that they need charging. So, yeah, it's all going good, and it's not overheating. It's running cool now. I put a new heatsink on my DC to DC step-up inverter down there. There's a big heatsink, that U-shaped thing, a big thing with black, and that is mounted on the microchip itself. I had to stick it on with some glue though because there was nowhere to bolt it, but and that's keeping that chip cold, and that's wedged in there between two lots of cells. And it doesn't even get warm, it stays cool though, so no worries there. Anyway, that's I suppose that's update 4, I think. Okay, right, well, I'll stand further back. You can see the panel a bit better when I stand further back maybe. Yeah, it is quite big actually, it's a lot bigger than the monitor. Right, okay, thank you for watching.